Hi everyone, and welcome to the Learning Curve Academy. In this video, I will be looking at angles and lines. Particularly, I will be looking at how to compute missing angles when two parallel lines, here P and Q, are cut by a transversal line T. Firstly, we are asked that suppose that the measurement of angle 4, so that's what M angle 4 here means, suppose that the measurement of angle 4 is 82 degrees. Find the measurement of angle 5. So let us go ahead and identify the angles of interest here, which are here angle 4 and here angle 5. These are our angles of interest. What we realize about these angles, 4 and 5, is that they are both inside of the two parallel lines, P and Q, and they are on the same side of the transversal. So because angles 4 and 5 are within the two parallel lines, it means that they are interior angles. Furthermore, because they are on the same side of the transversal T, then they are same side angles. So angles 4 and 5, by that reasoning, are same side interior angles. And what do we know about same side interior angles? Same side interior angles add to 180 degrees. So this means that angle 4 plus angle 5, so the measurement of angle 4 plus the measurement of angle 5 should equal 180 degrees. And again, this is because angles 4 and 5 are same side interior angles. Interior because they are within the two parallel lines P and Q, and same side because they lie on the same side here left of the transversal T. So since we know angle 4 already, we're given angle 4 in the question, so angle 4 is 82 degrees. So 82 degrees plus the measurement of angle 5 should give us 180 degrees. So this is easy to find since we now have only one unknown here, which is the measurement of angle 5. So 82 plus measurement of angle 5 is equal to 180 degrees. So what we're going to do here is that we're going to make measurement of angle 5 the subject, because that's what we're solving for. So since 82 is added to the measurement of angle 5, we're going to do the inverse of the addition of 82 degrees, which is to subtract 82 degrees. So we're going to subtract 82 degrees from the left-hand side of the equation to get rid of this 82 degrees on the left-hand side of the equation so that I'll only be left with the measurement of angle 5. But what you do to one side of the equation, you must also do to the other side. So I will also subtract 82 degrees from the right-hand side of the equation. Hence, I will simply be left with a situation where the 82 degrees minus 82 degrees here would be 0, so that's gone. So I'll be left with the measurement of angle 5 equal to 180 degrees, take away 82 degrees, which is going to give us 98 degrees. So the measurement of angle 5 is 98 degrees. That takes care of part A. Now let's go to part B. In part B, we're asked to suppose that angle 3 is equal to 127 degrees. So let's go ahead and let us locate the angles of interest. We're asked to suppose that angle 3 is 127 degrees and to find angle 5. So if this is angle 3 and this is angle 5, which they are, let us identify what properties these two angles satisfy. First of all, angles 3 and 5 are inside of the two parallel lines, P and Q. So because angles 3 and 5 are inside of the two parallel lines, we consider them to be interior angles. But what do we realize about angle 3 and 5 with respect to the transversal? With respect to the transversal T, what we realize is that angles 3 and 5 are on opposite sides of the transversal, or we could say on alternate sides of the transversal. So therefore, angles 3 and 5 are alternate interior angles. Alternate because they are on opposite sides of the transversal, but interior because they are inside of or within the two parallel lines P and Q. What we know about alternate interior angles is that they always have the same measurement when a transversal cuts two parallel lines, as we have in this case. So it stands to reason that the measurement of angle 3 would be equal to the measurement of angle 5, and this is because they are alternate interior angles. So since the measurement of angle 3, here is 127 degrees, then it stands to reason that the measurement of angle 5 would also be 127 degrees. So the measurement of angle 3 is equal to 127 degrees, which is also equal to the measurement of angle 5. They are the same. So the measurement of angle 5 is 127 degrees, which is the same as the measurement of angle 3 because they are alternate interior angles. So that takes care of B. Let's now go to C. C says, if the measurement of angle 5 is 109 degrees, find angle 1. So let us go ahead and do that. All right, so what we have here, let's mark the angles of interest. So we have here angle 5 and angle 1. Okay, so what we notice about angle 5 and angle 1 now is that they are firstly on the same side of the transversal that cuts these two parallel lines, T. Yes, they are both on the same side of T, which is the left side of T in this case. But what we notice further is that one of them, angle 5, is within the two parallel lines P and Q, and one is outside of the two parallel lines. So angle 1 is outside of the two parallel lines, but angle 5 is within the two parallel lines. So these two angles are what we call corresponding angles. So angle 5 and angle 1 are corresponding angles. And another example of corresponding angles here would, for example, be angle 6 and angle 2, using the same parameters that I just outlined. And what we know about corresponding angles is that they have the same measurement. They are congruent. When two angles have the same measurement, we say they are congruent. So the measurement of angle 5, which is 109 degrees, would be equal to the measurement of angle 1. So the measurement of angle 1 is also 109 degrees. This is because they are corresponding angles. They are corresponding angles because one of them is inside of the two parallel lines and one is exterior or outside of the two parallel lines, but they are on the same side of the transversal. And they have the same size. Okay? So three conditions are satisfied. They have the same shaping, same size. They are on the same side of the transversal, but one is inside of the parallel lines and one is outside. So these are examples of corresponding angles. As I indicated, another example of corresponding angles would be 6 and 2, as well as, for example, 8 and 4, and 7 and 3. Those meet all the conditions that I just outlined for corresponding angles. So that takes care of C. And now let's go to D. So D says if angle 7 is 102 degrees, find the measurement of angle 5. Let's go ahead and locate these. So we are told that the measurement of angle 7 should be assumed to be 102 degrees, and here we are interested in finding angle 5. So what properties do we notice about angles 5 and 7? Well, we realize that firstly they are across from each other and they have, well, the same size. They are vertical angles. Vertical angles are angles that are across from each other in situations where two lines intersect. Example, we see here that the transversal intersects line Q, and these two angles 7 and 5 are across from each other, so they are vertical angles. By the same argument, angles 8 and 6 would also be vertical angles, and vertical angles are equal. So by that argument, if the measurement of angle 7 is 102 degrees, then the measurement of angle 5 would also be 102 degrees. So here we go. The measurement of angle 7 is equal to 102 degrees. So if indeed the measurement of angle 7 is 102 degrees, then that would also be equal to the measurement of angle 5, which would be also 102 degrees. And this is because, again, the two angles are, well, vertical angles. So let's look at this. This angle here and this angle here will be vertical angles. Similarly, this angle here that I'm drawing using the dotted line would be a vertical angle for this angle. And vertical angles have the same measurement. They are congruent. So angle 7 here, guys, is equal to angle 5, which is equal to 102 degrees because they are vertical angles which are equal. All right, so thank you very much. I hope this was very clear and instructive and very useful, and that it will support you in your preparations for examinations at this time of the year and well after in courses like geometry or geometry aspects of your subjects. Thank you very much, everyone. See you soon. Remember to like, share, and subscribe to the Learning Curve Academy as we continue this amazing discourse in the learning of mathematics. Thank you.